All right, I guess we're getting started. Uh, Sorry that it's so difficult to find a seat in here. Try if you can. Uh, I want to get a quick idea of the people. I can't really see you, by the way, it's really bright. But I want to get a quick idea. Are most of you guys developers or business? Maybe I should give you some way to tell me that. Raise your hand if you're a developer. Okay, raise your hand if you're business. Cool. So I'm going to say that this is more of a technology focused type of thing, and that I don't have to feel bad about it. Okay. So we are talking a bit about the needs of our business and how we're trying to reflect them in our platform, but this is kind of focused toward developers. I promise not to pull any code. I promise not to pull very much code on the screen. I'll do my best. So let's jump into it. What we're going to talk about, I'll give you a quick introduction to who I am and to Hulu. We're going to talk about our data pipeline and what it is that we're processing with our data pipeline, which is what we call beacons. And then we'll talk about how we monitor and we have two different takes on that because there were lessons learned, hence the name. All right, so to introduce myself and to introduce Hulu, I figured I'd start with the photo wall. As soon as you go into the Hulu headquarters, you see pictures of everybody. When you work at Hulu, after you've been there for a few months, you get an opportunity to sit with a photographer, and you take a picture that reflects something about your personality. Sorry for the feedback. Something about your personality, or maybe it just reflects what you happen to have with you when the photographer showed up. So in my case, I forgot that it was my day, but I had swim goggles. And someone poured a bottle of water over my head as I crouched forward, and they took this picture. So it looks like I'm coming out of a pool, but really that's Dasani. Yeah. So I'm the team lead of a tool called Metrics and Reporting Tools up until yesterday. Now I'm the team lead of the data science team at Hulu. So Metrics and Reporting Tools is part of the overall metrics platform, as is data science. Metrics, we have the platform team, data science team, metrics and reporting tools, and the reporting team. So it's a lot of teams, and so we're folding metrics and reporting tools together with reporting and making it a general data accessibility. All this stuff is kind of org chart stuff. I'm not sure how relevant it is to you, so I'm going to kind of skip past it. But needless to say, what our team has been focused on and what I'm going to present today is the tools that we've made for platform instrumentation and data accessibility. All right, so Hulu. We're here to show people videos of TV shows, videos of movies. We're focusing on premium content. We're not as much a long tail provider. And what we offer that's different is an ad experience. So we're able to offer content that's only available when it's created or funded by advertisers. We have some different needs because of that, which I'll address in a second. We also pride ourselves on user experience. We try to put a lot of control in the hands of people so they can determine how they want to do things. The technology team, there's the description. I won't read it to you. This is kind of our mission or how we see ourselves. And hopefully you'll see this culture reflected in the apps that I'm going to show you. So what kind of data are we processing? We're processing these beacons that are fired from set-top boxes, mobile devices, website, and they're HTTP messages. So it's making a GET request. And if you're designing a Hulu app and you have to fire off GET requests for every kind of user event, like the user plays a video, the user paused a video, we played an ad, the ad finished, or the user bailed out before the ad finished. If you have to fire one of those every single time, it's very important to you that the service be highly available, because if it isn't, then it's going to impact the user experience. So this is what a beacon looks like. If you look over on the right-hand side, you'll see this query string. It's just an HTTP query string, and it has all the usual key value pairs. And we're trying to answer questions like the things on the left. What kind of shows are our users watching? What is their experience? Where do they, if they're on the site, where do they come from? Where do they click on? And this is how we process the data. In a way, you could look at this as a second table of contents for the presentation. These are the different phases of our data pipeline that we're going to look at. Right? So as developers, we're always monitoring. The business analysts need to extract data. The data pipeline is in green across the middle. And the processes we use to go from one point to the next are on the bottom. So we'll start by talking about ingesting the data. Right? The data that we're ingesting, on average, actually this is as of probably 2 years ago, on average it's about 12,000 events per second, peaking at 35,000, a little bit over a terabyte a day, uncompressed, and about, I think, 350 gigs compressed. All these are kind of rough estimates. If you kind of care to know more details, I can get them. Our constraint, the data never stops, and we can't lose any. So this is not just a data analysis question. Some of our distinguished competitors, they don't want to lose data either. None of us want to lose information that we can use to find out what's going on. But in our case, it's actually revenue. Every time somebody finishes watching a commercial, an ad on our platform, we get that beacon, and that's literally money for us. So if we lose information, we're literally losing money. So how do we do log collection? All these devices are sending these HTTP beacons across the ether, and we use Akamai as our CDN. That's the highly available part, right? So Akamai is able to respond very quickly. When people issue these GET requests, Akamai responds with a single pixel. I don't know what color it is, white, black, something. But they forward all these on to us. We have a server farm, we have a data center in El Segundo, and we have these 11 Nginx servers. So Nginx, if you're not familiar with it, is an open source HTTP server. Think of it as kind of like Apache, but really, really, really tuned for static content. Right? The traditional HTTP server model is threaded, and Nginx is based on more of a event-driven or a reactive model. So it's much more tuned for static content. So all these servers are just ingesting the data as logs. They're receiving these HTTP requests, and we get these big, long query strings. And then we use Flume to ingest it all into HDFS, and we bucket it by hour. So we have these files in HDFS that are represented by an hour and separated by different functions. So we have, or types. We have playback, we have what we call revenue, which is our ads, we have masthead clicks, we have a bunch of different types. All right, so what do we do with all this data? We get this data and we process it with MapReduce to get dimensions and metrics. So the red box on the bottom indicates a metric. It's the number of minutes that were watched in 1 hour across all of the dimensions above it. So one of the dimensions is right above it, the hour, which hour it was. And then we have which video it was at the very top, and a bunch of other, the details are kind of irrelevant. I just picked some random ones, and those aren't actual, that's not actual data. Okay, so how do we do our MapReduce processing? We have a number of technologies, and I won't go into them in detail. If anybody really wants to know more about them, just catch me offline, or we could do some questions at the end. I'll try to make time for that before the next presentation. But I can really quickly go over it. We have a domain-specific language we call Beacon Spec. Beacon Spec is a declarative language. So we use the primitives of this language are descriptors of a beacon. And the result of this language, what we're describing with this language, is a fact. So metrics and dimensions. So we use this declarative language to do the transformation that we saw on the previous slide and change this raw data into facts. And the way that we do that is we use a Beacon Spec compiler that creates MapReduce jobs. So the MapReduce jobs will process all of our beacons for us, including metadata lookups. So an example of that, let's suppose you wanted to do percentage of video watched. And the beacon coming in is a playback beacon, and it tells you how many minutes a particular user watched of a particular video ID. If you want to know the percentage completed of that video, you have to do a lookup to find the absolute length of that video. So part of the magic of the beacon spec compiler is it will actually insert the lookup for you. You just describe the content that you want with beacon spec, and it will provide all the lookups as well as the processing of the beacon. After we have all of these MapReduce jobs, we have a scheduler uses the actor model with Scala, and some of the projects that we have kind of underway or in partially completed mode are some automated documentation and validators. We do have some validation of our beacons as we're processing them, but the automated validators that we're talking about here are tools that we're building for, say, our mobile team so that they can run unit tests, and we can automatically generate those tests for them on the platform that they want. All right, the other way, so that's our typical MapReduce job. The other way that we process our beacons is called user jobs. So this is just a web interface. It's pretty straightforward. This is how our users can create ad hoc jobs to directly query our beacon files. And most people don't do this. This is only when there's something that goes outside of our data pipeline and they want another method of creating a MapReduce job without having to write a MapReduce job. And we do also have people directly writing MapReduce jobs, but only for a custom purpose. This is typically used by a data analyst, not by a programmer. And what they do is they specify a file type. So you see up there file type, and an example would be playback, which I think in the little gray text there it says that. So they may say something like playback, and they want to know how many beacons came in for a particular video, say. So they could use the regular expression field to say video ID equals whatever the video ID equals. And by doing that, they could match it, and the result of this job would be a list of the beacons that match that particular regular expression. Now, what one of our developers here, who's actually sitting back here, Mohammed, developed maybe a couple months ago, is this new mvel expression. So instead of using regular expressions, you can use mvel, which is a library that takes query strings, these key value pairs, and gives you a language that you can use to parse them for you. So instead of making a complicated regular expression where you have to know the order of things that happen and do an exact match, you can just use these primitives that come from Java strings, like the contains function. And then you can use Boolean logic to append things together. And this language will automatically be parsed by mvel and will create Java functionality in the MapReduce job that will match any of the beacons that meet these characteristics. All right, so back to the data pipeline. At this point, we've ingested the data from these beacon files, right? We've run MapReduce on them to create these facts. So now we have these hourly facts. We know, for example, how many minutes watched of a particular video, blah, 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 for this hour. So what we want to do is aggregate that. So if people are going to query our Hive tables, they don't just have to sum things across the hours. They can use our weekly tables or our daily tables or our monthly tables. So we have this aggregation process. This is a C# .NET application, a set of applications that runs to aggregate those. And then we also have our publishing process where we take the most popular data from our platform, data that's used downstream in various functions, data that's regularly reported on, and we push it to MySQL databases and some SQL databases. A lot of our financial data comes out here, and anything that drives views and revenue. So we talked about how the data gets pushed through, and that's pretty much the pipeline, ends in publishing. But then when people access the data, they use our reporting flow. And for the next couple of slides, I'm going to talk about the reporting portal that we have. This is the architecture for the reporting portal. I'll show you a couple screenshots, and from there we'll go to the monitoring tools, and that'll be pretty much the end. Okay, so this architecture here, we have, at the very top, we have this UI, this web layer, and everything that you do there gets recorded into this database. So we use a lot of JavaScript. So we're pushing these JSON objects back to our Flask app. We also like Python. And that gets recorded in this database that you see on the left. And then a separate component, this scheduler, which is written in Python, is regularly querying that database. So we have those disconnected just in case. We can take either one of them down and they don't hurt each other, so that's nice. And then we have this report controller that the scheduler uses to execute the queries, the reports that it needs to execute. And one of the functions that it's using, one of the services, is this data API service. The data API service, that's not really its name, but its name is so obscure as to be meaningless. I don't know why you would be interested in knowing that it's called Fortune Cookie, so I called it Data API Service. Most of our developers from Hulu are kind of looking at me like, what's the Data API Service? But what this thing does, you pass in metrics, dimensions, filters, you pass in date ranges, whatever data it is you're looking for, and it gives you back a query. It'll tell you this data is available in Hive, and here's the HiveQL to execute it, or it'll say it's available from this list of 5 tables in MySQL, and you have to join them. In some cases, it has to aggregate the data itself as part of the query, or it has to do a union of data that it got from various different places for the different date ranges. So it's essentially a query generator that works for MySQL, SQL, and Hive. That's also a .NET component. We've been thinking about rewriting that, but it's working pretty well. All right, and then after we have the query, the report controller is going to execute that query and then send out the report to the users. So, as promised, this is the reporting interface. This is the UI. We have a selection box being used at the top. And when you have selected the video views report, then you'll see this particular list of metrics. You can double-click or drag those metrics, whichever ones you're interested in, and then whichever the metrics that you've chosen will drive which dimensions are available. You then double-click or drag the dimensions that you want, and then from there we go on to filtering. So if you've selected video views and series title, you can filter on series title so that your report will only contain data for a certain show, for example. So what I've done here is I started typing the word Egypt in the middle. That's where the selector is. Everything you've selected is on the right. The things that you're actively selecting are in the middle, and it's filtered by whatever you type, your search. And then we have what we call presets on the left. So after I've made a particular selection, I could just select a bunch of things over here, and then I could hit save or save as. And when I save, I could save them as a preset. So instead of having to find every single kid series, I can do that search once and then save all of them, and then I just click that preset when I need to select those again. So after I've actually executed the report, I'm going to see a page that looks like this, the recent report runs page. And this will show the status of the reports. I can see that the ones on top are queued. I have one of them that's actively running. All 3 of them are running on Hive. I can tell that because they have a Hive ID on the far right side. And I can look at any of the ones that are already succeeded, and I can click the succeeded link to take me to the results page, or I can directly download the attachment that I created. There's an option. You can choose what attachment types you want for your reports. All right, so the whole point of this talk was lessons learned monitoring the data pipeline, but up until now we've just talked about the data pipeline. So thanks for bearing with me on that. I think we're like halfway through, so finally the meat of the topic. All right. Some of the problems that we've had with monitoring. When you have something like 800 MapReduce jobs running in a particular hour, and you've decided to program it so that when an error occurs or some condition or maybe even a warning occurs, that you'll just email yourself or email your team, you run into a certain problem, and that problem tends to recur every hour. So a lot of times we would come into the office and our inboxes wouldn't even open, right? Thousands of email messages, and some of them are just warnings. So you start filtering those out, and now you're not keeping track of that thing that you wanted to keep track of. We also have the problem that change is difficult. If we're publishing this data so that people can query it over long date ranges, we're not able to dynamically just switch which data we're publishing. We would have to go back and publish several months. But the publishing process can take long enough that publishing several months takes several months to do. We have all of these problems, I think, will be fairly familiar to somebody monitoring a data pipeline. All right. We have monitoring tools that are available. We try to use open tools. We're not trying to reinvent the wheel. We use the Cloudera Manager. We use OpenTSDB and Graphite to keep track of time series stuff. Our real goal here is that we want to be aware of everything going on in our domain. So the questions that we want to answer are not just how's our cluster and use tools for that. We want to know whether we're going to meet our SLAs. We don't just want to know how an individual component of our data pipeline is doing. We want to have the big picture, and we would prefer to have it all in one place. And we don't just want to know performance characteristics of a particular component of our data pipeline. We want to know it in context so we can know if it's meaningful. Right? So from a design perspective, we want to be able to access everything from a single point, right? Starting with a dashboard that will tell us if there's something that requires our attention. But we don't want to design something that's going to pull in data from our entire data pipeline and create another big data problem. So we went with a service-oriented architecture so that we have small components that are only responsible for one thing at a time. So here's one of our main dashboards. This is called MetStat. MetStat is a JavaScript application. It's using Django, Python web framework. Whoa, don't walk here, note to self. All right. It's using Django, a Python web framework to serve the pages. So what we're looking at here on the left-hand side is called an SLA clock component. And on the right-hand side is another SLA clock component. It's just configured differently. So this JavaScript component, you can feed it the number of hours and pipeline components that you're interested in monitoring. The one on the left is monitoring log ingest, jobs, and data sync. So you read it from the inside out. And here we can see that each of the hours for log ingest is green for the past day. It's a 24-hour clock in this case. So we see that the hour hand is pointed down, so it was noon when we were looking at this. And those hours are not yet complete, which is why they're hollow. But we also see for the past 24 hours that everything is filled in green, meaning that all of our log ingest happened within a typical performance window. Everything completed normally. Outside of that, we can see jobs. So for the past few hours, jobs haven't completed in this case. And going back, we see that jobs were delayed going back for a full 24 hours. And the mouse is hovered over a particular hour up here, and we can see that for the jobs in this hour, that 51 of them finished within a normal period of time. What is that number, 6 or 8? Some of them finished yellow. 8 of them finished yellow, which means that they were 2 standard deviations slower than normal. And then 1 of them finished red, which means that it finished 3 or more standard deviations slower than normal. And then outside of that, we see data sync hasn't been running at all. So data sync hasn't completed for a full 24 hours. So if we were looking at this, we would instantly know what part of our data pipeline is suffering. And the net impact of that, we can see on the right that our aggregations are almost complete, but there's some that haven't been able to finish, both yesterday and today. And the same with our publishings, because they can't publish something that hasn't been aggregated. So this allows us to see how the different pieces of our data pipeline impact each other. If you select any of the hours in this SLA clock, you'll see this little blue dot. I don't know how visible it is from out there, but there's a little blue dot here and right below it. And that means that that is the selected hour. And at the bottom of the page, where you see this horizontal representation of the data pipeline, the jobs that are listed and the status that they have are whichever hour that you have selected. So if you want to troubleshoot a particular hour, you can click that, hover over the job, and then you'll see what's wrong with it, or click it and get more details. From this page, you can also click the checkboxes and apply filters. And applying filters will make everything else disappear that's unrelated to the thing that you've selected. So if you need to troubleshoot something upstream or downstream, that's how you do it. So I won't go into all the details that you can get to from this dashboard. This is where we publish our documentation. So if you wanted to see what's going on with a particular job, you would click the link of that particular job, and you would see its recent run data. This is where we publish all of our counters. You'd scroll down, and you could see information about recent runs and so forth. You can see I chopped out a bunch of the pages. You can see its recent deployment history, in case that's relevant, if you find out it's recently been redeployed and been failing ever since. And a bunch of metadata. The particulars here aren't too important. Again, if anybody wants to talk about details, we could do that later. All right, so does this solve the problem that we have? Single point of access, success. Are we maintaining our services separately? Yes. All right. But from our user's perspective, we're detecting problem issues, we're troubleshooting well, we're taking care of things. We know that something's running slowly or whether we're going to meet our SLAs. But we're not able to tell particular users whether they're going to be impacted by some of the issues that we're having. So from our user's perspective, they're part of some sort of user group at Hulu, and they run reports. And some of the reports succeed, and some of them fail. Hopefully most of them succeed. And all those reports use some sort of data pipeline resources, but it's not something that they want to keep track of. Right? So we want to connect our issues to business units. We want to be able to find out who's going to be impacted when we have a component of our data pipeline down. So we're going with a graph data structure. So the question of why we use a graph instead of a relational database, it's not impossible to find this information out with a carefully crafted query using SQL. But we have to know every piece of our data pipeline, and we have to join our metadata about each of those pieces from front to end. So we get a really, really long query. Whereas with a graph, we just pick two nodes and say connected, yes or no, right? So it's a much simpler effort from the programming perspective. Why didn't we use a tree? A tree data structure is very similar. It's a subset of a graph, but in our case, it doesn't apply because we have some recombinant scenarios. All right, so using these data structures, we have this tool. And the guys responsible for it are right in this neighborhood over here, and I don't know where the other one is, but so they designed this interface, which I think looks very nice, and I'm going to show you how to use it. Okay, so this information, actually, let me go back a page. At the top, you can see that there's a date range, and you can select the date range. And we don't really need to click fetch reports. As soon as you select the date range, it just changes. So, I don't know, there's a candidate for getting rid of a button, I think. But when you select the date range, all the information on this page changes to reflect the period that you're investigating. It could be just today, for example. And then you can pick which of these boxes over here you want to look at. So we have last status, duration, the user department. And I'll show you an example of using this. Okay, so in this case, we've deselected from last status everything except failed. So now, if you go to any of these other boxes, the cross-filtered column reflects only things that are failed reports. And you can select from multiple boxes at the same time. I haven't really shown that in this particular demo. But you can use this to drill down across your different resources to find out what's going on. In our case, when we investigate which things failed, we can see that some of them have an unknown database or data store. What this indicates is that these failed before they even got to a data store, somewhere in our controller probably. The Hive failures that we have all hit a common table, but this table is a very popular table anyway, so that doesn't really give us much information. So what we want to do, all these rows at the bottom that you can see, the filtered reports, this list changes as you make your selections at the top. So as you drill down on the things that you're interested in from a particular data source, affecting particular users or user groups, or hitting particular tables, and all the other characteristics you can see on the right and some more that didn't show up, this report list changes, and then we have a log link on the right-hand side. So this is what it looks like. It goes all the way back to that architecture diagram where we had these various different components. Those components are written in different languages. We have a lot of Python and Scala. We have C#. We have, obviously, a lot of Java. So this controller, the one that I have open, this is the log file for this particular report on the controller. In order to make this happen, we have to have a common ID that spans across all of these different systems. So that was part of the effort that we needed to undergo to do this. And then we implemented a service on each of these components so that we could fetch a log file for that particular ID. So from a troubleshooting perspective, what this allows us to do is pass on responsibility. As developers, we love to build systems, but supporting them is something we would like to turn over to someone else. And we can't do that in good conscience until we make it really, really easy for them to support it. All right, so that's all I got. We found the important questions, and we built instrumentation for them. Our goal was to make it easy to troubleshoot, and we used a service-oriented architecture, and the actual technologies become much less important, I think, when you do that. And before we do the questions, I want to give some thanks to some of the people who got me up here. Kevin in the back, and Jim, and Randy, who got this stuff hooked up to me, which is functioning marvelously. And I especially want to thank these guys on the metrics team. Mohammed and Chris and Charlie are right there, and Robert's around here somewhere. And they're the guys who built all this stuff. So thank you, guys. Any questions? Can you come up to the mic?
Couple of questions.
Sure.
Can you, again, reiterate what those reports were built in? And then secondly, do some of these monitoring statistics feed into like your data center for them to actually monitor 724?
So the first thing was, wait, I think I overshot. Reports. You wanted me to pull open the reports?
No, I mean, what are they written? What are they built in? What are you
I'm
using
sorry,
for presentation?
yes. So the reports themselves are kind of just data dumps. And the final output of the report, some of our users use Tableau.
Well, no,
Excel
I
is
mean
very popular.
these monitoring dashboards. The
The
dashboard, what do you
monitoring
build?
dashboard. I
Yeah.
got you, sorry.
Yeah.
JavaScript, mostly. We are very fond of Knockout as a library. We've rolled our own for some small areas. We have some jQuery and stuff like that.
Okay.
Probably leaving out something important there, but I can follow up with you afterwards to make sure.
And then do they feed into like your data center? If you've got a data center that's running, 724 monitoring hardware and infrastructure, do any of these alerts or anything feed into that?
These dashboards don't feed back to our data center. We do have other monitoring specific to the data center that's being monitored by our DevOps team.
Can I talk to you offline about what you're using for that?
Yes. Hey.
Hi. Hey, you showed a data flow that shows your logger data flow in, streaming into HDFS, and then getting exposed as a Hive table.
I think that was way back at the beginning.
Yeah, so I'm curious what kind of latency elapses between when somebody does something in Hulu, like starting a show, hitting pause, whatever, and when you know about it, when it flows into your Hadoop cluster and becomes visible in your metrics. Are we talking seconds, minutes, hours?
We're usually talking hours. So we have different data pipelines. We have what we call quality of service beacons, and we have a real-time effort for that, which is focused on somebody's having a technical issue, or do we need to do something adaptive to account for user experience. This data is mostly for strategic purposes. So this is kind of like videos viewed and revenue and stuff like that. So we don't use real time with this data pipeline.
Okay, but it sounds like you're saying you do have another pipeline that gives you a lower latency picture
Yes.
of things.
Yes.
Thank you.
All right. I guess we're all set.